There are several reasons behind the trend to list equipment short-circuit ratings at TNCA. Firstly, manufacturers design equipment to exceed minimum standards for safety and reliability. By listing a short-circuit rating of TNCA, manufacturers ensure that the equipment can withstand even extreme fault currents, providing a margin of safety. Secondly, a higher short-circuit rating is often perceived as more desirable. It gives customers the perception that they are getting greater ability to protect against electrical faults. By listing equipment at TNCA, manufacturers can gain a competitive advantage. Thirdly, while not a universal standard, many electrical codes and installation guidelines recommend using equipment with a short-circuit rating of TNCA or higher. To comply with these recommendations, manufacturers may list their equipment at TNCA even if its actual rating is lower. Fourthly, testing equipment for higher short-circuit ratings can be expensive and time-consuming. By listing equipment at TNCA, manufacturers can reduce testing costs and potentially pass the savings on to consumers. There are limitations to consider when listing equipment at TNCA. Equipment listed with a short-circuit rating at TNCA may not be able to withstand that level of fault current in all cases. If equipment fails to operate as expected during a fault, it can pose a safety risk. Furthermore, customers may pay a premium for equipment listed at TNCA even if their specific application does not require that level of protection. It is important to determine the actual short-circuit rating of the equipment before specifying or installing it. This ensures that the equipment is suitable for the intended application and provides adequate protection against electrical faults. The 2023 National Electrical Code provides direction on short-circuit current ratings, or SCCR, in Article 110.10. This section focuses on circuit impedance and other characteristics. The impedance, component short-circuit current ratings, and other characteristics of the circuit to be protected must be selected and coordinated to permit the circuit protective devices to clear a fault to protect people, equipment, and to minimize damage to the electrical system. This fault can be a short circuit or ground fault. Equipment must be suitable for the available short-circuit current. Section 110.24 covers available fault current markings. Service equipment and other than dwelling units must be legibly field marked with the maximum available fault current. The field marking must include the date the fault current calculation was performed and be of sufficient durability to withstand the environment involved. Where modifications or additions to the electrical installation occur that affect the maximum available fault current at the service, the field marking must be adjusted to reflect the new level of available fault current. This is not required to be marked on dwelling units. Section 409.22 covers short-circuit current ratings. A controller or assembly, including all installed components, must have a short-circuit current rating. The rating must not be less than the available short-circuit current. This includes the available fault current at the line terminals of the controller or assembly. An exception exists for specific applications. Individual control equipment or assemblies can be marked with a short-circuit current rating. The short-circuit current rating must be based on one of the following. Firstly, it can be based on an approved method. Secondly, it can be based on the short-circuit current rating of a listed and labeled assembly. Thirdly, it can be based on the combination of a specific overcurrent protective device and the specific assembly. This must be tested per UL 580. Or fourthly, it can be based on series ratings. The controller or assembly must be legibly marked in the field. The available short-circuit current, the date of the calculation, and the name of the person performing the calculation is required. In industrial installations, the available short-circuit current and the date the calculation was performed must be documented and available to those authorized to design, install, operate, or maintain the equipment. Section 430.8 covers overcurrent protection. Motor control equipment must be protected against overcurrent. Where the motor control equipment is connected to a branch circuit, the overcurrent device must comply with specific sections based on the type of protection provided. Where the motor control equipment is connected to a feeder, the overcurrent device must comply with specific sections based on the type of protection provided. Section 440.4 covers marking requirements. Air conditioning and refrigerating equipment must be marked with its short-circuit current rating. The marking must be located so that it is visible after installation. If the air conditioning and refrigerating equipment includes a motor compressor, the marking must also include the locked rotor current of the motor compressor. In summary, these sections of the National Electrical Code address short-circuit current ratings. They address the requirements for marking, calculation, and coordination of equipment to ensure safety and proper operation during fault conditions. The code mandates that equipment is suitable for the available short-circuit current. This is typically documented through field markings and calculations. Always consult the latest edition of the National Electrical Code and local amendments for the most up-to-date and accurate requirements. Also, consult with a qualified electrical engineer or inspector for specific applications and interpretations. Short-circuit current rating, or SCCR, refers to the maximum short-circuit current that a component or assembly can safely withstand. It is a critical parameter for electrical safety and equipment protection. The SCCR is typically expressed in kiloamps or kA. It indicates the level of fault current that the equipment can endure without causing damage or creating a safety hazard. Equipment with a higher SCCR can withstand higher fault currents. This provides a greater level of protection. The SCCR is usually determined through testing. Testing is done according to industry standards such as UL 508A. The standard is for industrial control panels, or it is determined according to UL 489, which is for molded case circuit breakers and circuit breaker enclosures. These tests simulate fault conditions and verify the equipment's ability to withstand the specified short-circuit current. The short-circuit current is also based on calculations. The available short-circuit current at the equipment's terminals must be known. The SCCR of components and assemblies is crucial for several reasons. Firstly, it ensures personnel safety. Adequate SCCR helps to protect workers from electrical hazards. This could include arc flash and electrocution. This can occur during a fault event. Secondly, it protects equipment. Proper SCCR prevents damage to equipment and minimizes downtime in the event of a short circuit. Thirdly, it ensures code compliance. Electrical codes and standards, such as the National Electrical Code, or NEC, require that equipment be suitable for the available short-circuit current. This is at the point of installation. The selection of components and assemblies with appropriate SCCR values involves several steps. Firstly, you must determine the available short-circuit current. Calculate or obtain the available fault current at the equipment's terminals. This calculation should consider the utility source transformer and conductor impedances. Secondly, identify the SCCR requirements. Determine the required SCCR based on the application and applicable codes. Thirdly, select components with adequate SCCR. Choose components and assemblies with SCCR values that meet or exceed the calculated available short-circuit current. Fourthly, coordinate overcurrent protective devices. Ensure that overcurrent protective devices, such as fuses and circuit breakers, are properly coordinated. This helps to protect the equipment and clear faults quickly. Here are some of the common misconceptions. One is the belief that a higher SCCR is always better. While higher SCCR provides greater protection, it may not always be necessary. Specifying an SCCR significantly higher than required can lead to unnecessary costs. Another misconception is that the SCCR of the weakest link determines the overall SCCR. The overall SCCR of an assembly is determined by the lowest rated component. This is in the short-circuit current path. However, proper coordination of overcurrent protective devices can improve the overall system protection. A third misconception is that SCCR is only important for industrial applications. SCCR is important for all electrical installations. This includes commercial and residential applications. Understanding and specifying appropriate SCCR values is essential for electrical safety and equipment protection. It helps to ensure compliance with electrical codes and standards. SCCR considerations help minimize the risk of electrical hazards and equipment damage during fault events. Short circuit current rating is a critical factor. It ensures electrical safety, equipment protection, and code compliance in electrical installations. It is important to understand how to select equipment with adequate short circuit current ratings. Equipment should be selected for the specific application. This can help to minimize the risk of electrical hazards and equipment damage.